A circle with equation x squared plus 2x plus y squared plus 2y equals 4 has center C. FAE is a tangent to the circle at A with EAB equaling 33 degrees. Question 4.1. Determine the coordinates of C. One way you could do this is by completing the square. So question 4.1. If we write out our equation as x squared plus 2x and we complete the square, so we take half of this value, so half of 2 is 1, and you square it, then plus y squared plus 2y, and then complete the square again, so half of this value, so 1, and then square it. That's going to equal 4 plus the 1 squared plus the 1 squared. Now this becomes x squared plus 2x plus 1, and then plus y squared plus 2y plus 1, and that's equal to 4 plus 1 plus 1, which is 6. Now we can factorize it, or rather write it each in its own bracket. So this part can be written as x, and then there's a plus here, so I'll put a plus here, and then the square root of 1 is 1. So x plus 1 all squared, then plus y, there's a plus here, so I'll put a plus there, and then the square root of 1 is 1 all squared, and that's equal to 6. Now from here I can get the coordinates of the center. So this point and this point. So the center C is going to be minus 1, so you change the sign here, and then minus 1 again. You change the sign. So again, completing the square, and then once you complete the square, you change the sign to get the center point. Then question 4.2. Determine the equation of the tangent to the circle at A. So they want the equation of this line. Now what we do know is that since it is a tangent, the gradient of that green line multiplied by the gradient of this yellow line will equal minus 1. So first we need to work out the gradient of the yellow line. So the gradient of AC, that's equal to y2 minus y1 divided by x2 minus x1. I'm going to say 1 minus minus 1 divided by minus 3 minus minus 1. That's equal to 2 over negative 2, and that's negative 1. Now, going back to the point that the product of the gradients are going to be negative 1 because the lines are perpendicular. So the gradient of line AC times the gradient of line FE is going to equal minus 1. If the gradient of line AC is minus 1, that means we can calculate the gradient of the line FE. The gradient of the line FE will equal minus 1 divided by minus 1, which is 1. Now we can work out the equation of the line. We can say y minus y1 is equal to m into x minus x1. We substitute the point A now. So A is minus 3 and 1. So y minus 1 equals 1 into x plus 3. So y is equal to x plus 3 plus 1. Y is equal to x plus 4. So that is the equation of the tangent to the circle at A. Now moving on to question 4.3. Determine the value of k if y equals x plus k will be a secant to the circle. Now a secant is a line that goes through the circle. It cuts through. So we need to consider what values of k will this line be a secant. So if you look at the gradient of this line, y equals x plus 4, the gradient is 1. And if you look at the equation that they've given us, y equals x plus k, the gradient is also 1. So we can imagine that the line that they are talking about here is going to be this green line. And so how does this green line need to be shifted so that it becomes a secant? So if the green line is shifted down here, it'll be a secant. If it's shifted here, it'll also be a secant. If it's shifted there, it'll be a secant. And lastly, if it's shifted here, that's the last point. It won't be a secant at this point. Here, it'll be a tangent. So it'll be a secant anywhere between this point and this point right here. And so what we do need to do then is we need to work out the coordinates for D and then work out the equation of this line here, this new line. And so K just needs to be between this point and this point, because any value between that will result in the line being a secant to the circle. So let's focus on working out the coordinate for D. Now we can use the sliding method to work out the coordinate for D. It's quicker. So what we can do is we'll focus on this vertical distance here and this vertical distance here. Since C is the midpoint, the vertical distance must be the same. So remember, C is -1 and -1. So if you are going from 1 to -1, so we're looking at the y values, how many units down are we going? So we are going 2 units down. So then the vertical distance from C to D must also be 2 units. And so D will be -3. Now if you look at the horizontal, it's going from -3 to -1. It's going 2 units to the right. So that means from C to D, it should also go 2 units to the right. So -1 plus 2 is 1. So the coordinate for D is 1 and -3. Now that we know the coordinate, we can work out the equation. So we'll say that y minus y1 is equal to m into x minus x1. Now at point D, that's 1 and -3, y plus 3 is equal to 1 into x minus 1. So y is equal to x minus 1 minus 3, y is equal to x minus 4. So what that means is, if we draw a line that is parallel to that green line, that line will look something like this. Let's fix that. So this point right here is -4. This point right here is 4. And so if we draw this line, or if we shift that green line anywhere between those 2 points, so anywhere here, the line that's shifted will then cut the circle and will be a secant to the circle. So the answer then is that K should be between -4 and 4. Let's move on now to question 4.5. So question 4.5 reads, another circle with equation x plus 3 all squared plus y plus 2 all squared equals 4 is drawn. Will the two circles intersect? Okay, So first, let's figure out what the center of that circle is going to be. So the center of that circle, x plus 3, so the center is going to be minus 3. And x plus 2, remember we changed the sign, so with x plus 2 it becomes minus 2. So the center is minus 3 and minus 2. And the radius is going to be the square root of this number here. So the square root of 4, the radius is 2. Now let's go over what it means in theory if circles cross, if circles don't cross, if they touch at one point, and so on and so forth. So suppose we have a circle like this, some generic circle. Let me redraw that, like so. And I have another circle like this. And now they're clearly touching at one point. So if I take the radius of the circle, let's call that r, and let's call the radius of this circle right here, let's call that r prime. If I add them, so r prime plus r, if that is equal to the distance between the centers, so using distance formula, if it's equal to the distance, then we can say that the circles will touch at one point. Now let's consider if the circles are far apart. So if I have a circle like this, and if I have a circle like this, we will repeat here. If I call that r, and I call that r prime, and I represent that this is the distance between them. So if the distance between the centers is greater than the sum of the radii, then the circles are not going to intersect. They do not intersect. And of course we have the last scenario then. If I have a circle here, and I have another circle here, and if I call that's the radius, and I call that the radius, so r prime, and that's the distance, let's call that d. If the distance is less than the sum of the radii, then they will intersect. Now, all we need to do is we need to evaluate our current scenario. So our current scenario, we have a circle with the center minus 2 and minus 3. Let's just double check. Minus 3 and minus 2. So minus 3 and minus 2, and the radius was 2. Then we have another circle, which is minus 1, minus 1, and the radius of that circle is the square root of 6. So square root of 6. Now let's add the radii. So r plus r prime, that's going to be 2 plus the square root of 6. That's equal to 4,45. Now let's look at the distance between the centers. So the distance between the centers can be calculated using the formula x2 minus x1 all squared plus y2 minus y1 all squared. So x2, let's call that minus 1, plus 2 all squared, and minus 1 plus 3 all squared. That's going to give us a distance of 2,24. So let's look at our evaluation. Here we can see that the distance is less than the sum of the radii. So if the distance is less than the sum of the radii, then they do intersect. So the circles will intersect.